Hello and welcome to Math Success GH. In today's lesson, we are diving into the Binomial Theorem, a powerful mathematical tool that helps us to expand expressions quickly. If you are preparing for BECE or WASSCE, this is a must-know topic. So stay with me till the end and don't forget to like, share and subscribe for more math lessons. Do you remember how to expand s plus 2 all squared? I'm sure you do. S plus 2 all squared means s plus 2 times s plus 2. Now to expand this, you multiply the first term in the first bracket, which is x, by our whole second bracket, which is x plus 2. Then you multiply the second term in the first bracket, which is 2, by our second bracket, which is x plus 2. Now x times x gives us x squared, x times 2 gives us 2x. Let's expand the second bracket. 2 times x gives us 2x, and 2 times 2 gives us 4. So now since 2x and 2x are like terms, we can add and get x squared plus 4x plus 4. Very simple. Now, imagine you are asked to expand x plus 2 raised to the power 5. That means you have to multiply x plus 2 by itself 5 times. That is very tedious. But this is where the binomial theorem provides a shortcut, an easy way to expand this without having to multiply any binomial expression repeatedly. So let's get into the binomial theorem. For any binomial expression a plus b raised to a power of n, the binomial theorem states that it can be expanded as the sum of the terms from n combination k times a raised to the power n minus k times b raised to the power k. Now, at first glance, this formula looks a little scary, but we are going to break them down step by step, and I promise you they are going to be easy to work with. Let's take a look at the first part. This is sigma k equal to 0 to n. What this simply means is that we will be performing additions from k equal to 0 to n, which stands for the power of our binomial expression. Then let's take a look at the last part, which is a raised to the power n minus k times b raised to the power k. What this means is each term contains a raised to a decreasing power and b raised to an increasing power. So what we'll just be doing is, in the first term, it will just be n minus k, which is set to 0. So in case n is 3, then we are going to have a raised to the power 3 minus 0 times b raised to the power 0, and b raised to the power 0 is 1. Any number raised to the power 0 is 1. So which means you will just be left with a raised to the power 3, and there will be no b. Plus, then in the next term, we reduce the power of a by 1 and increase the power of b by 1. Then we keep doing this till we get to the last term, where a is raised to the power 0 and b is raised to the power 3, which is n. Let's look at the last part. The last part, n combination k, is just n factorial divided by n minus k factorial times k factorial. This part is very important because it helps us to calculate the binomial coefficient of each term. And as you can see, it has a lot of factorials in there, which means factorials are very necessary in this topic. So let's go take a look at factorials. A factorial of a number is denoted by an exclamation mark and is the product of all positive integers up to the number. For example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. Let's do another example. 7 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So you keep reducing the number and multiplying them till you get to 1, which is 5040. Let's do a lot more factorials, as factorials are very important for binomial theorem. Let's do a third example. 6 factorial divided by 4 factorial. Now, here, we know 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. But we can see that 6 times 5 times, then the 4 times 3 times 2 times 1 is equal to the 4 factorial. This technique is what you'll be using to make simplifying factorials very simple for us. So 6 times 5, instead of writing out the whole 6 factorial, we know 6 times 5 times, and the rest is 4 factorial, so we keep 4 factorial. Then in the denominator, we have 4 factorial, and the 4 factorial can cancel out the 4 factorial in the numerator, and we are just left with 6 times 5, which gives us 30. The fourth example. Let's take a look at 10 factorial divided by 3 factorial times 7 factorial. Now here, we do the same thing we did in our previous example, where we don't expand out all the factorials, but as we expand 10 factorial, 10 times 7 times 8 times, then we get to 7 factorial. And in the denominator, we expand the 3 factorial, then we keep the 7 factorial without expanding it, because 7 factorial can just cancel out the 7 factorial in the numerator, and we are left with 10 times 9 times 8, which is 720, divided by 3 factorial, which is 3 times 2 times 1, which is 6. Now 720 divided by 6 gives us 120. Now you might be wondering, what about 0 factorial? Well, by definition, 0 factorial is equal to 1. This might seem a bit odd at first, but it's a crucial part of any mathematical formula, including the binomial theorem. Now let us try and see how 0 factorial is equal to 1. So now first of all, we know 5 factorial is 5 times 4 times 3 times 2 times 1, which can be written down as 5 times 4 factorial. Now, it means that to find the factorial of any number, you can just write out the number times the number minus 1 factorial. Simple, right? Now we know 1 factorial is 1, but we can rewrite 1 factorial as 1 times, then 1 minus 1 is 0, 1 times 0 factorial. Now since we already know 1 factorial is 1, and 1 times any number is the number itself, 1 times 0 factorial gives us 0 factorial, and we know 1 factorial is 1, and therefore 1 is equal to 0 factorial, and that is how can we get 0 factorial as equal to 1. So let's take our first example, s plus 2 raised to the power 3. So here, our n is equal to 3. So let's expand this by calculating the coefficient of the first term. And the coefficient of the first term is 3 combination 0, which is 3 factorial divided by 3 minus 0 factorial times 0 factorial. And then the term is going to be x raised to the power n, which is 3, times 2 raised to the power k, which is 0. Since it's summation, we do this addition again, plus 3 factorial. Don't forget the formula is always n factorial. So it's 3 factorial divided by, this time, since we perform the addition again, the k will increase to 1. So it's going to be 3 factorial divided by 3 minus 1 factorial times 1 factorial. Then our power of x will reduce by 1 and 2 will increase by 1. So we are going to get x squared 2 raised to the power 1. Normally we don't write 2 raised to the power 1, but since this is our first example and I'm taking it step by step, I'm going to write them so you don't get confused. Plus, we do the combination again, but this time our k has increased to 2. So we get 3 factorial divided by 3 minus 2 factorial times 2 factorial. Then our x, which is raised to the power n minus k, has now reduced to 1, and our 2 has now increased to a power of 2. Plus, we do this again, 3 factorial divided by, this time our k is 3, so 3 minus 3 factorial times 3 factorial. Then our x has reduced to a power of 0, and our 2 has increased to a power of 3. Now let's simplify it further. 3 factorial is The first part is now 3 factorial divided by 3 factorial, because 3 minus 0 is just 3 and 0 factorial is 1. So we are left with 3 factorial divided by 3 factorial times x cubed, and the 2 is gone because 2 raised to the power 0 is 1. So 1 times s cubed is still s cubed, plus the second term gives us 3 times, and we expand. If you remember what we did, instead of writing out the whole factorial of 3, we just make it 3 times 2 factorial, because we know in the denominator 3 minus 1 will give us 2 factorial that we can cancel out from the numerator. So we get 3 times 2 factorial divided by 2 factorial, and 1 factorial is just 1. So 1 times 2 factorial is still 2 factorial. Then we have x squared times 2 raised to the power 1 is 2. Plus we go to the third term, then we do the same expansion again, because we know that in the denominator we have 2 factorial there. So we do 3 times 2 factorial, then 3 minus 2 is just 1. So 1 factorial is 1, then times 2 factorial, then times x times 2 squared, plus in the last term, since the denominator is 3 minus 3, we get 0. 0 factorial is 1. So we get 3 factorial divided by 3 factorial times 2 cubed. Now remember, x here is raised to the power 0, so there's no power of x. Then we come down, and 3 factorial divided by 3 factorial is just 1. So they cancel out, and we are left with x cubed, plus here 2 factorial cancels out 2 factorial. So we are left with 3 times x squared times 2, and 3 times 2 gives us 6. So that gives us 6x squared, plus the third term, 2 factorial cancels out 2 factorial. 2 squared is 4. So we get 3 times 4 times x to give us 12x, plus in the last term, 3 factorial cancels out 3 factorial, and we are left with 2 cubed, which is 8. Then we are done. Very simple. Just in 3 steps, we've been able to expand s plus 2 cubed. Let's do another example. Let's expand x minus 3 raised to the power 5. So x minus 3 raised to the power 5. Our n is 5, which means the k we start with is always, don't forget, is always 0. So let's first calculate the coefficient of the first term, and that is n combination k, which, if you remember, is n factorial divided by n minus k factorial times k factorial, which means we have 5 factorial divided by 5 minus 0 factorial times 0 factorial. Then we multiply x and negative 3. X is raised to the power 5 and negative 3 is raised to the power 0. Then we move on to our second term, plus we calculate the coefficient. 5 factorial divided by, now our k moves from 0 to 1. So it becomes 5 minus 1 factorial times 1 factorial. Then x reduces from 5 to 4, and negative 3 increases from 0 to 1. Plus, we calculate the coefficient of the third term, which is 5 factorial divided by 5 minus 2, because now the k is 2, times k, which is 2 factorial. The x reduces from 4 to 3, and the negative 2 increases from 1 to 2. Plus, let's do the coefficient of the next term, which is 5 factorial divided by 5 minus 3 factorial times 3 factorial. X again reduces from 3 to 2, and negative 3 increases from 2 to 3. Plus, the next coefficient of the next term is 5 factorial divided by 5 minus 4 factorial times 4 factorial, and the power of x reduces to 1, and negative 3's power increases to 4. Now in the last term, the coefficient is 5 factorial divided by 5 minus 5 factorial times 5 factorial. the power of x reduces from 1 to 0, and negative 3 increases from 4 to 5. Now, notice a pattern in them. The powers of the two terms always sum up to n. Always. So 5 plus 0 is 5. In the second term is 4 and 1, which is 5. In the third term is 3 and 2, which is 5. And so on and so on. And each of them always have to sum up to the power you were given in the question. So let's simplify this. In the first term, we get 5 factorial divided by 5 factorial, because 5 minus 0 is 5. 0 factorial is just 1. Times s raised to the power 5. Negative 3 raised to the power 0 is just 1. So 1 times s raised to the power 5 is still s raised to the power 5. Then in the second term, we expand to get 5 times 4 factorial divided by 4 factorial. I hope you understand how we came by this. Then times s raised to the power 4 times negative 3, because negative 3 raised to the power 1 is just negative 3, plus, and in the third term, we know in the denominator we are going to get 5 minus 2 factorial, which is 3 factorial. And so doing, we expand the top as 5 times 4 times 3 factorial, so we can cancel 3 factorial from the denominator. You get it? So we get 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial. In the next term, we have 5 times 4 times 3 factorial again, because we know in the denominator, which is 5 minus 2 factorial times 3 factorial, we have a 3 factorial in there that we can cancel out. Then x is raised to the power 2 and negative 3 is raised to the power 3, plus 5 factorial divided by 5 minus 4 factorial, which is 1 factorial, which gives us 1, times 4 factorial, and the x exponent reduces from 2 to 1, and negative 3's power becomes 4, plus 5 factorial divided by 5 factorial, because 5 minus 5 is 0, and 0 factorial is 1. 1 times 5 factorial is still 5 factorial. Let's move on to the next step. So 5 factorial cancels out 5 factorial. So we are just left with s raised to the power 5. In the second term, 4 factorial cancels out 4 factorial, and we are left with 5 times s raised to the power 4 times negative 3. In the third term, 3 factorial cancels out 3 factorial from the numerator, and we are left with 4 times 5 all over 2 factorial. Now 2 factorial is just 2, because it's 2 times 1. So 5 times 4, which is 20, divided by 2 gives us 10. So we get 10 x raised to the power 3, and negative 3 squared is positive 9. Okay, the square of any negative number is positive. Move on to the fourth term, and 3 factorial cancels out 3 factorial. We are left with 5 times 4 again, divided by 2 factorial, which is just 2, and we get 10 x raised to the power 2, and negative 3 raised to the power 3 is negative 27, plus, in the next term, 4 factorial cancels out 4 factorial, and we are left with 5 x raised to the power 1 is x, and negative 3 raised to the power 4 is 81, plus, in the last term, 5 factorial cancels out 5 factorial, and negative 3 raised to the power 5 is negative 243. So let's simplify what we have. We are left with x raised to the power 5. Negative 3 times 5 gives us negative 15, x raised to the power 4, plus 10 times 9 is 90, so we get 90 x raised to the power 3. Negative 27 times 10 gives us negative 270, we get s raised to the power 2, plus 5 times 81 is 405, so we get 405x minus 243. So let's do a third example, x plus 2y raised to the power 4. Now here you can pause the video, try this example on your own. Put your answers in the comment below before you check out the solution. Alright, let's get into it. So here, you calculate the coefficients by using n combination k. Here our n is 4 and our k always starts with 0. So we get 4 factorial divided by 4 minus 0 factorial times 0 factorial. Then you multiply x and 2y, but you raise x to the power of 4 and the whole of 2y to a power of 0. You keep doing that. Get 4 factorial divided by 4 minus 1 factorial times 1 factorial. Then you reduce the power of x from 4 to 3 and increase the power of 2y from 0 to 1. Plus, calculate the coefficient of the next term, which is 4 factorial divided by 4 minus 2 factorial times 2 factorial. You reduce the power of x from 3 to 2, then you increase the power of 2y from 1 to 2. Plus, you calculate the coefficient of the next term, which is 4 factorial divided by 4 minus 3 factorial times 3 factorial. You reduce the power of x from 2 to 1 and increase the power of 2y from 2 to 3. Plus, in the last term, the coefficient is going to be 4 factorial divided by 4 minus 4 factorial times 4 factorial. And here you reduce the power of x from 1 to 0 and increase the power of 2y from 3 to 4. Let's simplify this further. And in the first term, we get 4 factorial divided by 4 factorial times s raised to the power 4. 2y raised to the power 0 is 1. In the second term, we get 4 times 3 factorial divided by 3 factorial. And we have times x cubed times 2y. In the third term, we expand the top to get 4 times 3 times 2 factorial. Because we know we are going to get 2 factorial in the denominator where we can cancel out. Plus, in the fourth term, we had 4 times 3 factorial divided by 3 factorial. Okay, now you always check your denominator to find what factorial you get in the denominator. Then you expand your top to meet it so you can cancel them out. Times s raised to the power 1 is x and 2y cubed is 8y cubed. Okay, the power affects both of them. If you are having difficulty understanding this, go check out our video on indices where we tackle this. And in the last term, we have 4 factorial divided by 4 factorial times 2y raised to the power 4 becomes 16y raised to the power 4. The next step, 4 factorial cancels out 4 factorial, so you are left with s raised to the power 4. In the next term, 3 factorial cancels out, so you are left with 4 times s cubed times 2y. The next term, we have 6s squared times 4y squared, because 2 factorial cancels 2 factorial, and 2 factorial is just 2. 4 times 3 is 12, divided by 2, we get 6. In the fourth term, we have 4 times 3 factorial divided by 3 factorial, and they cancel out. You are left with 4 times 8y cubed. In the last term, 4 factorial cancels out 4 factorial, and you are left with 16y raised to the power 4. So let's do our multiplications. We are left with x raised to the power 4 plus 4 times 2y gives us 4 times 2 gives us 8, which means our second term is 8s cubed y plus 6 times 4 gives us 24. And we are left with 24s squared y squared plus 4 times 8 gives us 32. So that gives us 32x y raised to the power 3 plus 16y raised to the power 4. I hope you got the answer correct. Let me know in the comments below. Let's try this question where it says find the coefficient of s squared in the expansion of 3s plus 4 raised to the power 5. So this one doesn't want us to expand it fully. He just wants to know what the coefficient of the term with s squared is. Alright, so let's get into it. So we need to get to the term where we have x squared in the expansion of 3s plus 4 raised to the power 5. our n is 5, and at the point where s is square, our k is 3, because n minus k at the point, you have 5 minus 3 to give us our x squared. Okay, so our n is 5, our k is 3, which means the coefficient here is going to be 5 factorial divided by 5 minus 3 factorial times 3 factorial. And our terms in our binomial expression will multiply. So we have 3x times 4, and our n minus k at that point is going to be 2. So our 3x is going to be raised to a power of 2, and our 4 is going to be raised to a power of 3, which is our k. So let's expand. So you expand the top, you get 5 times 4 times 3 factorial divided by 2 factorial times 3 factorial. Then 3x all squared gives us 9x squared, and 4 cubed is 64. So when you expand further, 3 factorial cancels out 3 factorial, and 2 factorial is just 2. So 5 times 4, which is 20, divided by 2 gives us 10. So you have 10 times 9s squared times 64, and that gives us 5,760 s squared. So the coefficient of s squared in our expansion is 5,760. So now that we've covered the basics, it's time to put your knowledge to the test. Pause the video and try these examples. Number 1, let's expand s minus 7 all raised to the power 4. Number 2, let's expand 4s plus 2y all raised to the power 3. And number 3, let's find the fourth term in 2x minus 5 raised to the power 6. Just the fourth term. Take your time and answer these questions. And when you're ready, check your answers, because I'll be pinning the answers in the comments below. Check to see whether you are right. Thanks for watching. If you found this video helpful, don't forget to give it a thumbs up, leave a comment, and share it with your friends. And if you haven't already, hit the subscribe button for more maths tutorials like this one. See you in the next video.